Okay, here we are at part three. Part three, so we start with problem 21. Share screen. Let's do it. All right, so 21 through 25 are the rational expressions, your favorite. But we got to do them. So 21 says simplify, which is just factor. Oh, no. No, it's actually multiply or divide. And then simplify. Okay. So since we have division involved, this one here, we're going to flip that one. Won't flip the other ones, but just flip the one, the divisor one. All right, but everything's got to be factored. This is a difference of squares. I'm not going to spend any time on how to factor. Just going to go right to it. A plus 1, A plus 2. This factors into A minus 1, A minus 1. And this is A plus 2, A minus 2. And here we take out a 4A minus 2. That's your factoring. Then you get to cancel. A plus 1, A plus 1. A plus 2, A plus 2. A minus 1, A minus 1. A minus 2, A minus 2. Forward and forward. What do we got on top? 1. What do we got on the bottom? A minus 1. How nice is that? How nice is that? All right, how about you try this one? Uh, 3A, let's try that. And times, let's go. And how about just an A minus 3? All right, let's see what happens here. All right, so A plus 3, A minus 3. Flip this one, can factor it a 3, A plus 3. And difference of squares on top. Nope, mistake. That should be a minus. Hey, that should be a minus. In the bottom is A minus 3, A minus 1. So I already flipped that one. Let's go A plus 3, A plus 3, A minus 3, A minus 3, A minus 1, A minus 1. The 3 with the 6 leaving a 2. So on top, 2, A plus 1 on the bottom, A minus 3. All right, so that's how you do ones like 21. I'm going to skip ahead to 24 because 24 is just factor and reduce. What is that? What does that say? Getting tired, getting a little tired. All right, so we can factor to 4. Always look for the GCF first. And then it's difference of squares. In this one, through the power of magic Fiotio, or however else you do it, I think we're going to get 2x plus 3x. I think that's it, plus 6. Yep. Okay. X plus 3's cancel. That's not very interesting. That's not very interesting at all. But it's just factor and reduce. What if I didn't take out the GCF first? Then you wouldn't have got this canceling action, because if you didn't take out GCF, you'd have 2x plus 6, 2x minus 6, and nothing would have canceled. And then I'd take points off and you'd be like that. But if you do take the GCF, you'd be like this. All right, 22, 23 is add, subtract. No, 20, no. Oh. One of them was supposed to be add, subtract. All right, let me look at the test. 25 is supposed to be add, subtract. All right, we'll fix that when we get to it. So 22 and 23 are solved. Okay. And whether we're solving or adding or subtracting, our first step is to factor. This is x plus 5, x minus 4 conveniently. Find the LCD, which is I don't need to write it there. The LCD is x plus 5, x minus 4. And the deal was we multiply every term by this entire LCD. Clone, clone. All right, so I'm going to multiply by that LCD there, shrink it. I don't know why more teachers don't use a smartboard. It's just the best tool. Okay, so you multiply by the entire LCD because the point is when we have solve the equation, the denominators will cancel. It has to happen. It has to happen. No more denominator. It cancels. By multiplying by the entire LCD, you're guaranteed to find the canceling factor. Plus, all cancels, just 3 equals x minus 4. Okay, no more denominators. Now, let's go 3x plus 15 plus 3 equals x squared minus 4x. Alert, alert, we have a quadratic. Is that going to happen on the test on problem number 22? Yes, it will. Quadratic at 0 on one side, everything on the other side. I think it's going to be this. How did you do that? I subtracted 3x, I subtracted 18, and then we factor this, x minus 9, x plus 2. In the answer column, you write x equals 9, x equals negative 2. So on the test, that's what's going to happen. Cancel, cancel, cancel. You get a nice quadratic, and it will be factorable too. I can promise you that. So make little notes. Make little notes in your card. Number 21, I'm going to get a quadratic, but it's factorable. Whatever you need to do. 22 rather. That was 22. On 23, it's also solve. But it doesn't end up quadratic. That's good news. I'm going to pause for a minute. Back. Just had to check my phone. A text came in. All right, so this factors into x plus 1, x plus 3. What a surprise. Your LCD is x plus 1, x plus 3. So I put it here, in here, in here. As promised, the denominators will cancel. So I have x plus 3 minus x squared equals 2x plus 1. The good news here is the x squareds cancel, so it's not quadratic at all. You get x equals 2, right? Yep. All right, so this was number 23. So make a note, number 23 doesn't end up quadratic. That's good news for you. All right, then 25 it's a mistake on the worksheet packet. On the test, it'll say add, subtract. Oh, in the worksheet packet, it says add, subtract, but it's not an add, subtract. So this should have been a plus, not an equal. On your packet, that's an equal, it's supposed to be a plus. All right, so we still factor. Then you find the LCD and you keep the LCD. So you need an A plus 2, and A minus 2. So you write the LCD because you're adding fractions, right? If you add 1/2 plus 3/5, you still get a fraction. You'll still have that common denominator of 10 down below. All right, so we got our LCD. So now you multiply by what's missing. Look at it, look at it, look at it, look at it. It's missing an A minus 2. Look at it, look at it, look at it. It's missing an A plus 2. And we look at that, look at that, look at that. It's missing an A. So now you get 2 parentheses A minus 2. How about the denominator? Well, it's A plus 2, A minus 2. You got it, it's there. Minus 3 parentheses A plus 2 plus A. And you simply clean up the numerator. that right? So what do we get? Negative a, no, we get just negative 10, I think. Oh, did I do that right? Oh. Let's see, 2a minus 4 minus 3a minus 6 plus a. So that's negative a plus a, no a's. Yep, that's it. All right, so why don't you try this one? Add, subtract. All right, go ahead and try that. All right, so you factor in a and got a plus 3. Difference of squares. A minus 3. So your LCD, you need the standalone a plus 3, and a minus 3. So now what's missing from here? A minus 3. What's missing here? A. What's missing here? A plus 3. So our numerator, 3, parentheses, a minus 3, plus 4a minus, be careful, minus 1. Why am I saying be careful? Got to distribute that negative. So 3a minus 9 plus 4a minus a minus 3. Just be careful, you're distributing this negative. So we have 6a minus 12 over this. 7a, that's a 9. Yep, so 6a minus 12. You can factor out a 6, get a minus 2, but nothing cancels. So the factoring is not necessary there. All right, on to trigonometry. So 26, you have a point 2, 3. We don't have to be exact, but it's going to be in this quadrant. So that's 2, 3. And we go like this, and you make a triangle of reference. So x is 2, y is 3. And by Pythagorean theorem, find r. So x squared plus y squared equals r squared. 2 squared plus 3 squared equals r squared. 4 plus 9. So r is square root of 13. Yes? Just Pythagorean theorem on that. So this is obviously your x, and that's your y. There it is. So x is 2, y is 3, r by Pythagorean theorem. So now, if you have to find sine theta, it's y over r, which is 3 over root 13. If you have to find tangent theta is y over x, which is 3 over 2. I was going to come back to this. I should probably do it now. This 3 over root 13, we know we can't leave it like that, right? So you go root 13 over root 13. Final answer, 3 root 13 over regular 13. And how about secant? All I know about secant is find cosine and flip it. So cosine is x over r, 2 over root 13. But before I rationalize it like this over here, don't, because they're going to flip it anyway for secant, and there you go. That's a secant. You might say, oh, I didn't memorize tangent is y over x. I just memorized tangent is sine over cosine. That's groovy. Your sine was, let's backtrack, it was this, and your cosine was this. That's 3 over root 13 times root 13 over 2 when you flip that. And those cancel, you get 3 over 2. All right, so let me give you another one. How about you have the point -4 comma -4 comma 5. And then find cosine theta, we'll find tangent theta, and we'll find cosecant theta. All right, so -4 over 5, 4, 5 is this quadrant. Drop your perpendicular. So x is -4, r is 5. Use the actual signs. There's x, there's y. Use those actual numbers. because in this quadrant, yeah, x is negative and y is positive. Pythagorean theorem, square root of what, 41? 16 plus 25. Yeah, okay. So cosine, x over r. So cosine is negative 4 over root 41, which would be negative root 41 over 41 for cosine. Tangent we'll come back to. Cosecant, find sine, opposite over hypotenuse. Cosecant, you flip sine, and you get root 41 over 5. Get cosecant, and you flip the sign. All right, so tangent, you can say is sine over cosine. Well, sine, we just found is 5 over root 41. And cosine, before we simplified it, was negative 4 over root 41. How do you clean that up? That's 5 root 41 divided by this. So you flip the divisor. And there you go, negative 5/4. Or you can say tangent is opposite over adjacent. Why don't we just do it that way in the first place? That's easier. It's opposite over adjacent, 5 over negative 4. Okay. 27. Sine A is negative 12 over 13. And cosine A is greater than 0. You're going to find the quadrant and you're going to find tangent. Well, let's see. Find the quadrant. Where's tangent negative? Why did I say tangent? Where's sine negative? Sine's negative there and there. All sin, tan, cos. They're all positive there, so that means sine's positive there. Sin's positive there, it means sine's positive there. Tan and cos are positive there, so sine is negative there. Where's cosine positive? They're all positive there, so cosine's positive. Only sine is positive there, so cosine's negative. Only tangent's positive there, so cosine's negative. Cosine's positive there. So you are in quadrant 4. Okay. So in quadrant 4, here's what we got. Remember, sine is y over r. R is always positive, so it's 13. So the y must be the negative 12. Yeah, because in that quadrant, y is negative. So y is negative 12 and r is 13. Right? Sine is y over r. How do I know who the negative goes with? Well, r is always positive, so the negative goes to the y. And of course, in this quadrant, y is negative. All right, so that, and now we're going to find x by Pythagorean theorem. You do x squared plus negative 12 squared equals 13 squared. X squared plus 144 equals 169. You get x squared equals 25. So x is plus or minus 5. And in this quadrant, x is positive. In this quadrant, x is positive. So tangent, y over x is negative 12 over 5. That's it. That's it. One more like that. Let's say cosine A is negative 3/5, and sine A is less than 0. Find the quadrant and then find tangent A. Okay, if cosine's negative, we're here. If sine's negative, we're here. We're in quadrant 3. So cosine, x over r. R is always positive, so r is positive 5. So x must be a negative 3. Find y by Pythagorean theorem. You're going to get y squared equals 16. So y is plus or minus 4. But in this quadrant, y is negative. So y is negative 4. Right? In this quadrant, y is negative. So y is negative 4. So what's tangent? Y over x, which is negative 4 over negative 3, which is positive 4/3. Negative 4 over negative 3, positive 4/3, which makes sense because that's your positive tangent. Like all sin, tan, cos. All right. Starting to come down the home stretch here. 28 exact values. Cosine 120. 120 is going to be here somewhere. So if that's 120, you find your reference angle in there, and that's got to be 60. So cosine 120 is plus or minus cosine 60. Well, in this quadrant, cosine's negative, so it's negative cosine 60, and cosine 60 is negative 1/2. That's it. All right, how about tan 225? Well, 225 is going to be there. Reference angle, so that's 225. So the reference angle is here, which is 45, right? So tan 225 is plus or minus tan 45. In quadrant 3, tan is positive. So it's positive tan 45, which is 1. And finally, sine 210. Reference angle is 30, so it's plus or minus sine 30, and 210's down here. Sine's negative there, so it's negative sine 30. Sine 30 is 1/2, so negative 1/2. Okay. 29. These are the very first trig problems we did. Solve for x. This is our 3-player game. It's always going to be 2 sides and an angle. 2 will be known, 1's unknown. That's unknown. We're trying to find that side. 3-player game. What trig function we have? For this angle, that's opposite, and that's adjacent. So that's tangent. You write tan 38 equals x over 12. Multiply each side by 12, and you got it. Just punch that in. I don't know what that is, but you just punch it in and you got it. All right, so why don't you try this one? Nice triangle. And let's make that the x in 13. Okay, so find x this time. And for that angle, we've got adjacent, we've got hypotenuse. That's known as cosine 56 equals adjacent over hypotenuse. X is on the bottom, so multiply by x. So x cosine 56 equals 13. Divide by cosine 56. We're not using inverse cosine, we're dividing by cosine 56. So your answer for x is this. And again, you just punch that out and you got it. All right, the number 30. 30 was solving for an angle, and when you solve for an angle is when you use inverse sine or cosine or tangent. 3-player game again. I've got adjacent, I've got hypotenuse, that's cosine. So cosine A is 18.1 over 21.3. So A is inverse cosine of that, and you just punch that in and you got it. Okay. And 31. From the ground, you look up at your friends in the tree. It's not like grandma's in the tree. There's your friend. What is he doing in the tree, or she? Who knows? It's your friend. I don't know. So you're on the ground and you look up. Hey, what are you doing up there? At an angle of elevation of 51 degrees. Is that the angle of elevation? Yeah, it's horizontal in the sight line. Yep. If you were standing 18 feet from the bottom of the tree, 18 there, how high off the ground is your friend? So looking for this height, looking for x. 3-player game. Opposite, adjacent, that's tangent. Tan 51 equals x over 18. So your answer is 18 times a tan 51. I don't know what that is, 20 something maybe. All right, boys and girls, that is the end of the review. Wow. It's the end of everything. I guess period D will be doing some more stuff in class, but period A, that's the end of teaching guys anything new or review. So I'll see you one more time, period A, and that's in your final exam. I'll talk to you more about wrapping things up for your year and my career on when I see you, but yeah, I'll save it to then. So good luck in the review. Have a nice, this is Sunday of Memorial Day weekend, so have a nice Memorial Day weekend, yada, yada, yada. All right, Talk to you guys soon. Bye-bye.